This video is going to be about passive RL low-pass filters, and it's going to build upon material I covered in my RC filter videos, so make sure you've seen those first. And I'm going to show you a practical example, a simple audio crossover. Alright, so what is an RL filter? An RL filter is a filter made of an inductor and a resistor. We use the letter L for inductors because of the scientist Heinrich Lenz, who made some early discoveries in electromagnetism. Also, the letter I was already taken for current. Here's what a generic low-pass RL filter looks like. Now, as I mentioned in my first inductor video, inductors resist sudden changes in current. Because of this, inductors will filter out certain high-frequency signals, depending on the inductance value, and let the lower frequencies pass through unchanged. The cutoff frequency of the filter is given by this equation, and let's run through a quick example where I have a 100 microhenry inductor and a 50 ohm resistor. Plugging the values into the equation, we get a cutoff frequency of 79.6 kHz, and I'm going to round that off to 80 kHz. Here's a simulated Bode plot of the filter. You can see that low frequencies pass through the filter completely unchanged. As we get closer to the cutoff point, the amplitude of the signal starts to decrease. At the exact cutoff point of 80 kHz, there's a 29% reduction in amplitude. And after that, higher frequencies get heavily filtered out, with a 20 decibel reduction for every time the frequency increases by a factor of 10. Okay, let's do a practical example now. Let's say I want to put this 8 ohm woofer into a speaker cabinet that I'm building. And let's say I want a cutoff frequency of 2 kHz, so the woofer only handles low frequency sounds. Let's take the RL cutoff equation and rearrange it to find the inductor value we need. Plug in our values of 8 ohms and 2 kHz, and we get an inductance value of 637 microhenries. So I'm going to put two 330 microhenry inductors in series to get 660 microhenries, and that should be close enough. Okay, now you should be able to hear the difference with and without the low-pass filter. With the filter in the circuit, the higher frequencies get filtered out. Now that was just a simplified example with crappy components. If you want to do a better job, you should use an air core inductor, which will give less distortion. And Google around for audio crossover design guides. Now you might be thinking, what's the difference between this and an RC filter? Well, if you try to push more than a few milliamps through an RC filter, you get significant power losses. But with an inductor-based filter, the DC resistance of the inductor is almost zero, so you can draw a lot more current. Alright, that's it. Thanks for watching.